Hello everyone, this is Firoz Nadav. In this video, we will study flow through pipes, which is the topic of fluid mechanics 2 in Mumbai University. First, we will see what is the definition of a pipe. Pipe is a closed conduit which is used to carry fluid under pressure. There has to be some sort of pressure uh, so that the fluid should flow in a pipe. Okay, so if there is no pressure, there will not be any flow in the pipe. Now you see, when the fluid is flowing in the pipe, it is always subjected to resistance towards the flow. When we are talking about the real fluid, when the real fluid is flowing in the pipe, the flow is subjected to resistance, and there are two resistance the flow will experience. For example, the flow is in this direction, okay, in the pipe, and the resistance will be offered by the boundary in terms of friction. This is one resistance, and another resistance is viscosity of the fluid. Okay, for example, if these are the layer of the fluid flow, okay, so this layer will be resisted by this layer, and this layer will be resisted by this layer. So each layer will try to resist the other layer. In this way, we will have the viscosity of the fluid. The more viscous fluid is there, the more resistance will be there. Okay, so when the fluid is flowing in a pipe, there is a resistance, and the resistance are offered by two things. One is the boundary wall of the pipe, it will offer friction, and the viscosity of the fluid itself. Okay, because of the resistance offered by the boundary wall and the viscosity, there is some energy loss in the flow. In the pipe, there is some energy loss. We will see how to understand this energy loss. Okay, for that I will take a pipe, and I will define 2 points in a pipe. Whatever points I will define, I will insert a piezometer in that point. As soon as I insert a piezometer in a pipe, water will rise in the piezometer, and the rise of water will indicate some energy, pressure energy, okay, some energy. And at point 2 also I will insert a piezometer, and the water will rise. Okay, now you see the level, there is some level difference. Okay, so this is the level of a piezometer 1, and this is the level of piezometer 2. There is some level difference, and this level difference is nothing but there is some head loss from point 1 to point 2, and there is some, you can also say that there is some energy loss from point 1 to point 2, and this energy loss is because of resistance offered by the boundary wall and the viscosity. We have seen that there are some losses in the pipe. We can categorize those losses into two categories: major loss and minor loss. Major loss is due to friction in the pipe, because of major loss is due to resistance offered by the boundary wall. Okay, minor loss is due to sudden change in the velocity. uh, we have different mechanism by which the velocity of flow is changed, and because of that there is some loss, and those losses are termed as minor loss. In case of long pipes, we do have to consider major loss, but we can neglect minor loss when we are dealing with long pipe. Okay, minor loss may not impact that much in case of long pipe, but in case of short pipes we must consider minor losses. There is some rough definition: which pipe is called as long pipe, which pipe is called as short pipe. If the length is greater than 1000 times diameter, that type of pipe is called as long pipe. If length is greater than 1000 times diameter, this pipe is called as long pipe, otherwise short pipe. Head loss due to friction, or rather major loss, is estimated by using Darcy's Weishbach equation. Darcy's Weishbach equation is used for laminar flow as well as for turbulent flow, but most oftenly it is used for turbulent flow. So since it is used for turbulent flow, we have to we have to see the assumptions for fluid friction in turbulent flow. We have some assumption of fluid friction in laminar flow as well as in turbulent flow, but most oftenly Darcy's Weishbach equation is used for turbulent flow. That is why when we are dealing with fluid friction, we have to see assumptions in turbulent flow. So one thing we need to note, the fluid friction is directly proportional to velocity in case of laminar flow, but in case of turbulent flow it is proportional to v raised to n, where v is velocity of the flow and n can be varied from 1.72 to 2. So this is the thing that we have to take. Fluid friction is directly proportional to v raised to n, n is between these two values. To derive Darcy's Weishbach equation, again I will assume a pipe, and in the pipe I will assume two sections, section 11 and section 22. Distance between section 11 and 22 is L, where L can be termed as length of the pipe. So what I will do, I will apply Bernoulli's equation to section 11 and section 22. So we have to recall Bernoulli's equation for real fluid. You have to recall the statement of Bernoulli's theorem for the real fluid. What is the statement? Statement of Bernoulli's equation. The total energy at any section is equal to total energy at previous section minus head loss. For example, we are dealing with section 11 and section 22. Okay, total energy at section 2 equal to total energy at previous section, total energy at section 1 minus head loss or energy loss. Okay, so total energy at section 1 equal to total energy at section 2 plus head loss. So this is what we have to recall. Okay. So total energy at section 1, total energy is pressure energy plus velocity energy, which is also termed as kinetic energy or kinetic head, plus datum head or datum energy, is equal to total energy at section 2 plus head loss. Okay, now you see we have assumed that we have drawn horizontal pipe. So in case of horizontal pipe, whatever datum you will assume, Z1 will be equal to Z2. If you are assuming this as a datum, you see this will be your point 1. You have to consider center of the pipe at section 1 and center of the pipe at section 2. Okay, so this will be the Z1 and this will be Z2. So whatever datum you assume, when you are dealing with horizontal pipe, Z1 will always be equal to Z2. Okay, now you see by continuity equation, what is continuity equation? Continuity equation is uh, Q equal to A1 V1 equal to A2 V2. What is A1? A1 is area of pipe at section 11, A2 is area of pipe at section 22, V1 velocity at section 11, V2 velocity at section 22. So you see, since the pipe is uniform, uniform means diameter is same, diameter is not changing. Since the pipe is uniform, A1 is equal to A2, and by continuity equation V1 will be equal to V2. So velocity is same and datum is equal to 0, datum is also same, so this part and this part gets cancelled. Okay, so you are getting P1 by rho g equal to P2 by rho g plus head loss. P1 by rho g is nothing but pressure head at section 11, and P2 by rho g is nothing but pressure head at section 22. So head loss equal to pressure head at section 1 minus pressure head at section 2. So you have to note this as equation number 1. One more law we have to recall from the physics, that is Newton's second law of motion, F equal to m into A, where F is force, m is mass and A is acceleration. You see, we have discussed about it that the boundary wall will offer some resistance. There is some force, resistance force offered by the boundary. We have to calculate the magnitude of this resistance force. It can be called as frictional resistance. This force will be called as frictional resistance. To calculate this, we will define F dash. Let F dash be the frictional resistance. See, we are very much interested in frictional resistance. Let F dash be the frictional resistance per unit velocity per unit area. F dash equal to frictional resistance divided by V raised to n into area. Why we have taken V raised to n? Because Darcy's Weishbach equation is often used for turbulent flow. For that we have to use the law of fluid friction for turbulent flow. Okay, so area, here you see area, you simply cannot take the cross sectional area of the pipe, because friction is there in the inner surface of the pipe, at the boundary wall of the pipe. So how to find the inner surface area? For that, what we have to do, we have to calculate the circumferential length into length of the pipe. If you multiply these two entity, you will get the surface area. So what is circumference? Circumference is 2 pi r, or you can write 2 pi into d by 2, where d is the diameter of the pipe, or simply you can write pi d circumferential length into length of the pipe. So this whole thing will give you surface area, inner surface area, or circumferential area. Okay, so this is what you are getting. From this you can calculate frictional resistance. Frictional resistance equal to F dash into V square into pi dl. N can be taken as 2. We have discussed about it. Now we will define what are the different forces that are acting in the pipe. Already we have defined two sections, section 1 and section 2 and we know that there are some pressure energy at section 1 which is P1 by rho g. Similarly at section 2 we have some pressure energy, that is P2 by rho g. Because of those pressure energy, you have some forces at section 1 and section 2. To find that force, what you have to do, you just have to multiply P1 into cross sectional area. So F1 will be in this direction, F2 will be in this direction, and frictional resistance will be against the flow. The flow is in the right direction. Okay. Now as per Newton's second law of motion, summation of F equal to m into a, mass into acceleration. We will assume that the flow is steady. What do you mean by steady? Steady means the velocity does not change with time. The velocity of the flow does not change with time. So what is acceleration? Acceleration is nothing but change of velocity with respect to time. So here velocity does not change with respect to time. Dv by dt equal to 0. Dv by dt is nothing but acceleration. So since acceleration is 0, summation of F will be equal to 0. Okay, so just consider all the forces, take all the forces. F1 is going in the right direction, frictional resistance is going in the left direction, F2 as well is going in the left direction. So what is F1? F1 is P1 into cross sectional area. F2 we have frictional resistance we have calculated. Okay, so we have not written F dash here. Okay, F dash will be there, and this is F2. Okay, F dash will be there. So what we will do, we will solve it. P1, P2, pi by 4 d square is common, you can take it. You will get pi by 4 into d square in bracket P1 minus P2 equal to this. Equal to this you will get. Here F dash will come. F dash will come. Okay. Okay. Pi will get cancelled. P1 minus P2 equal to 4 F dash L V square by D. This is what you get. After this, what we will do, we will divide both the side by rho g. Okay, so we are dividing both the left hand side as well as right hand side by rho g. What is rho? Rho is the mass density and g is acceleration due to gravity. P1 minus P2 divided by rho g, and the right hand side term divided by rho g. So already we know that P1 minus P2 by rho g is nothing but head loss. Already we have defined one equation. From equation 1, it can be written as H, head loss. Okay, H equal to 4F dash L V square by rho GD. We have some empirical relation. 4F dash by rho G equal to F by 2G. We have some empirical relation, means based on some experiment. You know F dash is frictional resistance per unit velocity per unit area. F is friction factor. Okay, when you're solving the problem, sometimes in exam they will give you the value of friction factor. They may not give the value of F dash, but they can give the value of friction factor. So we can use this empirical relation for F dash by rho g equal to F by 2g, and we can substitute in the equation. So H equal to F L V square by 2gd. Now one more empirical relation we have, F equal to 4 F double dash. This is also one empirical relation, and we can make use of this, where F double dash is coefficient of friction. You can just substitute it. H equal to 4 F double dash L V square by 2gd. Most of the time in exam, you see, when you're solving the problem, most of the time they will give you coefficient of friction, and when coefficient of friction is given, you can make use of this formula. So this is a formula by which you can calculate head loss due to friction. You can calculate head loss, major energy loss in the long pipe. Thank you everyone for watching this video. Thank you very much.